the same issue. So I need to know what kind of list I'm going to have. So what am I going to store inside of that list? So I'm actually going to have this weird implementation here, where I put a generic within a generic. So you can see how this code can get a little bit gnarly, because you can have actually, most of the time you have a collection, like a map, of some things, which could actually be another map of some other things, like a list or an array. So that's why we're doing it together. So we had a string as our key and a list of strings as our value. And so now every time I have states, well, let's start at the very bottom. So the end goal here, I'm going to sys out my states. Wow, states. I'm going to go ahead and print those out at the very end. So if I want to add a state, for example, I'll have states.put. I'm not going to add to the map because put is going to be the word that we use for maps. I need to put in a key value pair, and Eclipse is nice at helping me out with that. So let's say Texas, and then my value needs to actually be in list of some sort, but it doesn't really matter what type of list. So I'm going to say new array list of strings. But that's going to put an empty array list into my data structure. So that's not very helpful. It's not actually going to list anything for me. So I can go ahead and I'll take the initialization out here, and I'll say list string tx equals the thing I was about to do there. And then we'll put tx down here. And now whatever I add to tx will be added into, bless you, Texas as the map. So tx.add, for example, and I can add something to that list. So let's go ahead and add one. We'll add San Antonio. But I can also add other ones as well. I can say tx.add, wow, add all, and I can add a collection. So if I wanted to add a bunch at once, instead of saying San Antonio and Austin and then Houston and whatever else, I can add all at once. And this time I can actually have maybe a listing. So I'll have Austin and Dallas and Corpus Christi. Did I do that? Yeah, okay. And you get the idea. All right, so we've added a bunch, not all necessarily, but we've added a bunch. And now it's saying that the references here don't change. So what happens is I've created this array here, and I'm trying to add it as a collection. I might try to add curly braces, and it's still not quite getting what I need it to be doing, right? Because an array, a regular array in Java, isn't a collection in the sense that it's not a data structure that falls into one of those things. It's not a class. So I need to convert between the two. I'm going to actually use arrays, that helper class, and there is a method called asList. So I'm going to take asList and wrap that around my list here. And I can just pass in a bunch of things. It'll convert the list of things, or all the things that I just passed in, into an array, basically an array list. And then add all will take a collection and put that into my array list and kind of append onto the end. So it's doing a few things for me. This is just sample code so that you can see how we might interact with add versus add all, putting some things in there, and I'll go ahead and I'll just print out what we currently have so that we can see what's going on. So right now, if I print, it's going to have Texas equals, and then the array list that contains all of the things that were in there. So we will note a few things. One is that San Antonio came first, and then Austin, Dallas, Corpus, because that's the order we added them in, and lists are ordered, so that's important. We can have duplicates, so there's no issue with us adding duplicates in here. Let's go ahead and add another Dallas for no apparent reason. And I will run it, and now we have 2 Dallas in here in our list because duplicates are allowed. They're just being treated as objects. And if I were to add another state, let's say that I did this again, and we'll just do it again for one more state, and I'll fill it in quickly so you don't have to worry about any of this. We'll call this one New York, because I'm out of state. New York. So we'll do NYC, Albany, different output. Down here, it's still going to have that curly brace because it's printing out a map for me. But first it prints the key. It prints an equal sign. This is not important for you to remember, just so that you can read this out later on if you do see this. But you see a key, an equal sign, and then the listing, and then a comma, a key, an equal sign, and a listing. So it's kind of trying to print everything in a way that indicates there's a key value pair going on here. Here's the key first, and then here's the value. And this is really easy to see if you do what was on the previous slides with like Alice and then her phone number and Bob and his phone number and everything, but I figured that's kind of your hello world. This one's a little harder to kind of visualize because you have a map data structure with another data structure inside of it. But we're all still using strings, so it's kind of easy still to visualize. All right, so this code, let's go ahead, I'm just gonna take this. And I'll actually I'll update the slides that are on there so that you have just this example. Wow, really? That's awesome. There you go. So I'll update those a little bit later. In our ebook reader, we had an array list for our books. Is that still a good choice, knowing that we have other data structures available to us? Should we change our implementation of that in-class example as we go forward to be something else? My first thought is maybe we have a hash map instead. So maybe instead of sorting an array list or keeping track of some arbitrary ordering of the books, like probably the ordering that we read them in the directory, we could read them in and then decide as a hash map, let's get the certain title. Maybe the author can, or the user can request a certain author or a certain title of a book. That might be a little bit more convenient. All right, let's talk about generics, because we've kind of been talking about generics. We've kind of talked about the greater than, less than sign, but the implementation behind it's something really important to understand as well. But generics, and we've used them before, they're going to enable us to have types in our classes. So we have types of array lists, we have types of collections, types of things we're going to store, but there's so much more than that. We can start implementing them in our code as well. So again, if we have that list of strings, for example, I could declare my list. In this case, it's an array list without giving the generics the greater than, less than sign. I could add something to it. In order to take something back out, I have to use that in blue, cast that thing to a string. So I have to say list.getZero is going to be a string, I promise every time, and if it doesn't work at runtime, I'll get an error. So they enable us to do that. We can change it very easily by adding the generics. In this case, they're in blue, so I'm going to say I have a list of strings. And then whenever I say list.getZero or list.getSomeIndex, I don't have to cast it, I don't have to tell it it's going to be a string, because it knows automatically every time. So this is the part of generics we should be kind of comfy with at this point. This should make the most sense. We don't need to do the casting, that's great. But in addition to eliminating casting in the previous examples, we also get these better type checks. So at compile time, it's going to go through and type check everything that we have. And because Java is a strongly typed language, this is really important. You might notice in Python, for example, if you get into Python, you don't have to declare what a variable is going to be ahead of time. You can just say A equals something, and it'll just save whatever the result is into A. Java's not like that. It needs to know exactly what's going on, and you get stronger type checks with generics than you would without them. And that, again, kind of circles back into that eliminate typecasting issue, but you'd rather find these kind of issues at compile time than at runtime. It also enables programmers to implement generic algorithms. This is the part we haven't gotten to yet and we're going to talk about now. So you're actually able to write generic algorithms without having to worry about what types they operate on. So we're going to write some generic algorithms that are going to be in the form of methods and classes that you won't necessarily have to declare what types they are. This is going to allow you to focus on the algorithm instead of the syntax. So if you wrote this one really awesome algorithm that worked for one type of something, maybe one type of character in a game, and you needed to abstract it a little bit to work for all characters in your game, you'd be able to use generics for that. So we're going to use that in a few examples to be able to create some things, and we'll still be able to create very clean, very type safe, and very customizable kind of code without having to reinvent the wheel every time. So generic methods is an easy place to start because if we jump right into classes, it gets a little confusing, especially with objects and polymorphism and everything else. So methods are a little bit easier, but the idea here is that you can create methods that you can reuse. And just to do this, we'll create a really silly basic one where it takes an array of numbers, returns a random element in the array. So choosing random things is sometimes important. If you guys are creating a game, for example, maybe you want something to show up randomly. I'm hoping you already know about the random number generator, but if you don't, I'll use it in some of the code here. And to do this, let's say that all I want to do was take an array of numbers, or integers, and get a random value. So we're not getting into generics yet, we're just writing a method that maybe might be useful for some piece of code somewhere. So I write the method, I'm going to call it random integer, pass in an array of integers, and I want to get back an integer. Random equals new random. This creates a new random number generator. So if I ask it for the next value, it's going to, bless you, find the next value, or choose the next random number. So random.nextInt looks just like scanner.nextInt, right? Kind of like from the console. So it's getting the next integer value. It's going to be passing in a number of some sort. So array.length. If I get next int from a random number generator, it's going to choose a number between 0 and 1 less than the number I pass in. So if I pass in 10, it'll be a number between 0 and 9. If I pass in 100, it'll be 0 between 0 and 99. So it gives me the next integer value, 1 less than the number that I pass in. And that'll give me, fortunately, because we're zero-based indexing, an index for the item maybe in the array. I can use that index to get an integer and get the result. So let's say we wrote this whole algorithm and we decided this works really well, it's very sophisticated. Now I would like it to work on string arrays. I need to go back and reinvent this entire thing, right? So I've written this and it works for integer arrays, and I need to take an array of strings now and return a random element in that array, and that time it's going to be a string. So I rewrite the entire piece of code, and pretty much the same, with a few differences. I'm going to take in a string array, I'm going to get the next int, still random.nextInt, because it's still a random number I'm generating. But then I have a string result, and I'm returning a string of some sort. So there's a little bit there. So let's look at these side by side. The only thing I changed to be able to do this is a few of the highlighted words in red. Integer on the first line, and then integer on the result, string on the other ones. And if I wanted to write one to generate to choose a random user, maybe they have I have an array of characters or avatars or something, and I want to choose a random one, I'd have to do the same thing all over again. I'd rewrite the same algorithm over and over and over again, the same code. So we don't want to do this. We want to use generics to avoid this. And what I'm going to do is I'm going to keep all the code just from one of these methods, but I'm going to take the red items out and replace it with something generic. So instead of having string or integer in that location, we're going to replace it with the letter T. Yeah. So capital T in this case is going to represent something. And when the user wants to call this method, they're going to have to define what something is ahead of time. So you'll notice that there's a T as the return type, and then a T array is what's passed in as the parameter, and then it's a T result that's chosen. And T is now my type for that method. So it can be a capital double, a capital integer, it could be a cat. It doesn't really matter what it is, as long as T is all the same thing. And then right next to public, we have greater than less than sign, and there's a T inside of that. That indicates that the user needs to actually declare what T is going to be ahead of time. So when they call this method, they need to decide what T is going to be. And when they say random element, they have to pass in something, and that T has to be the same. So public sub greater than less than T is going to say this is going to be a generic method. So don't go looking for t.java. So the compiler is going to say, okay, T is generic. I won't look for t.java. I'll go find something else. The user is going to pass in a string array, for example, they'll get a string back. If they pass in an avatar array, they'll get an avatar back. So we can call this a couple of different ways, and here's two ways to call it. We're going to use integers and strings this time, because maybe we still want those two implementations. I'm going to have maybe an integer array and a string array that are just really basic regular arrays, no fancy collections here. And I can have this dot, so I'm assuming that this is already kind of connected inside of a main method or another object method, for example, where it doesn't need to be static. But this dot random element, so I'm going to call random element with int array. It's going to give me back an integer, and random element with a string array is going to give me back a string. We didn't have to make any other changes to the code. So we don't need the previous implementations. We just need this one piece of code and these arrays. So that's pretty convenient, right? If I had to get a random item from an array or from a collection of some sort, and I didn't know ahead of time what type it was going to be, or if I needed multiple cases, and they weren't already related in terms of polymorphism. So if I can't say, for example, I can't say an integer is a string, so there's no relationship between those classes like that, no is a relationship. So I'd want to make something like this where it's generic enough to take anything. So this is great for methods, but it gets even cooler for classes. So we can take it one step further. Instead of just a generic method, I can also say I can create a generic class. So that was a really great example for using something where I might just have one algorithm, but what if I have a whole type or a whole series of algorithms that I need? In that case, I'll create a generic class. And the concept here is that Java, only the compiler is really going to process this, so it's going to go through, and if you've created an array list, for example, of strings, it'll compile the array list class for you, knowing that it's a string, instead of knowing that it's any other type of item. So the compiler is the only one who cares about your generics, which is really nice. It's very convenient for kind of downsizing the amount of code you have to write. The compiler is going to use it to ensure your type safety, but there's no type checking at runtime. So you write the entire class generically, or you use ArrayList, for example, and that's a generic class. When you actually run your code, the compiler's gone through, compiled everything down, and if you had an array list of strings and an array list of integers, it takes that generic code, makes a customized one for strings, makes a customized one for integers, and at runtime, it looks exactly the same. It just thinks that there's two classes, one for array list of strings, one for array list of integers. But you didn't have to write the code twice, which is really nice. Actually, you never had to write the code at all, right? We borrowed that from the Java framework. But if you wrote your own class, you wouldn't have to do that. And so the compiler's the only one who cares. Nobody else cares. You won't see it anywhere else, which is really nice. And they're essentially going to be the same thing as we just talked about in our methods. This is chapter 18 in your previous textbook, but I'm going to dig into generics.zip, which is going to have a few examples in there. So we're going to look at pair tests, pair of same type, and a few examples. So let's pop over there. So there's a project called Generics. They weren't stretching too hard here. There's one for the generic methods that we just kind of talked about. So the same thing, so if you're looking at the random element, you want to test some of these out, you might test out some of the code that's in here, kind of left over from previous semesters. I'll warn you that not all the code that's included is as clean, so you might go in and like format, for example, or add some lines in there if it looks a little bit too chaotic to look at. But let's look at pair tests. This is a little messy. All right. So, it's not like this. All right, so let's look at this class. This class is called pair of strings. So, same idea as our method, where I might implement the same thing more than once, or you might wind up creating the same class more than once, and you might need to lean on generics a little bit, because this might get a little bit crazy. So let's start with pair of strings. I have a class that's just going to hold two strings for me, first and second. It has a constructor in it that takes in one string and two string and then assigns them, and then some getters and setters, or just getters. So I have get for first and get for second. So I think this is great. My algorithm in here is great. I have some really great implementations for different things, maybe as additional methods I'm thinking of adding to this. And then it turns out I also need a pair of integers, maybe. So I create a pair of integers class, and it has an integer first and second, and it takes in those two, and I have getters for both of those. And you're kind of tempted at this point to think, do I need polymorphism? So do I need an interface, for example, or do I need an abstract class? Should I be leaning back on some of those? And you have to think, is there an is-a relationship? So when we talked about polymorphism, we used UML, we talked about how one thing is another thing. And if you can't say that, so my pair of strings is not a pair of integers, and my pair of integers is not a pair of strings, those are weird, so it means there's no polymorphism here. There's no interface, no abstract class. But there's probably an opportunity for generics. So let's say instead of these two classes, we have probably the temptation first to think a string and an integer, capital I, they're both objects. So let's write a generic looking class like this. And you'll see this code on the internet a lot. Something like this, where you have a pair of objects and your object type is an object. So now it seems like it's generic, like in the English sense, not in the Java sense. It seems like it's generic enough where it takes in two objects, it doesn't matter what they are, and it stores them. However, later on when you go to take them out, you have to know what they are, because you can't call any methods on them, and everything in Java is an object, so you have no idea what you just pulled out of this object. So get first, for example, you'll get an object back, but you'll have to figure out what it is, or cast it to something and hope for the best at runtime. So we don't want to do this. This is a big no-no. We don't ever want to follow this kind of thing. Instead, we want to write a generic class for this. So we might call this pair of same type. So first and second were both the same type. So we're going to use something like this. Instead of having a type here, so I had a pair of integers, was private integer first and second, took in an integer. Everywhere there's integer highlighted, I'm going to replace it with the letter T. So pair of same type, private T here, and there's going to be a T, object 1 and object 2 that's taken in. Get first returns a T, and get second returns a T. And that's going to create a generic class for me. This T at the very top, this greater than less than sign, is just like the declaration for array list. So that's what array list looks like. It looks like public class array list sub T, and then later on when you create your array list, it fills in T with whatever's needed. So the compiler actually goes through and creates a brand new array list implementation of strings every time you need one. And it's kind of nice and efficient and quick that way. But you can write your own generic classes like this and say, I'm going to have two things of the same type, I don't care what they are, just allow everything in this class to be T. We can take this a step further and say, you know what, first and second don't actually need to be the same type. But I need to change my implementation for this. Instead of saying just one type T, I need to add another generic letter. So pair of different types in this case is going to say first and second are going to be two different types, and this is how we declare more than one generic. And this is how map gets away with what it does. Map had that key value pair where it had two different things, and they could be anything you want them to be, because it has two different things that it's storing in two different generic types. But they have to be two different capital letters. Capital is important. One single letter, but it can be pretty much any letter that you want to, which is nice. R, S, and T are the ones you're going to see the most. They're kind of the most generic in the code, and they stand out to Java developers. But you can see that everywhere, if I pass an S first, S goes to first, T goes to second. So anywhere I reference object 1 or first, that's going to be an S type object. Anywhere I reference object 2, it's going to be a T type object. So in my getter, I need to make sure my getters look a little bit different, where the first getter, getter for first, returns an S, and getter for second returns a T, whatever those two values are. So we can write code to call these two. I can go ahead and create a pair of different types, the same way that I would for any other array list or other classes. I'm going to go ahead and type this in. So I'll write this little method here. So I can say pair, pair. There we go. So a pair of different types, and I have to provide an S and a T. It's telling me that ahead of time. And I'll call it pair 1 equals new pair of different types. So I can create my own generic ones. I can even pass in the two things as a part of the constructor. Let's not do this here, because that might be something that's new. Let's use the regular constructor. And now I have to specify S and T. So it's not enough for me to say, yes, I know that they're different. Here in the implementation, I actually have to do the same thing I would with an array list. So let's say I have a pair of different types, and I'm going to have a string and a double. Then in this case, I have to change it over here as well to match exactly the same thing, string and double. So it's going to store two things together with it. And that means I'll be able to create my own pair one of two different types. I can system.out.print pair one. We all know that that's not going to work. Why?
No two string.
Yeah, there's no two string. So it's going to print garbage. But the reason that this isn't compiling right now is because the constructor is not defined. So let's go back to different types. So a pair of different types has a constructor and it takes in two items into the constructor. There's no generic constructor or no empty constructor left. So there's no constructor out there that allows you to create something with empty parentheses. So it means I have to pass in two values when I'm creating this item. If I want to fix that, I can go ahead and create a new public pair of different types and not pass anything in at all. However, that relieves that requirement. So in my test, for example, I've just created a pair of different types with no information in them. And now I can print it out, whatever that might be. And so nothing really happened to really construct my item. So I want to make sure that if you choose to do this empty parentheses, that there's a reason for it. That the user should be able to create this item. So if I'm sitting here and I'm looking at this and I say, well, the user should be able to create a pair of different types that contains no data. It doesn't really make a lot of sense. So I'm going to remove that. I can pass in two things. And I'll have to pass in a string first. So hi, and a double, I'll pass in. It's got to be a double. There we go. All right, so now if I run this code, I'm going to get junk, but we'll run it anyway. So it'll give me the package name, which is generic classes. Again, don't follow this all the time. Dot class name, pair of different types, at junk. All right, so our generic classes were cool. Next time, let's pick it up. We'll talk about